everyone, and welcome to a special episode of Eyes on Earth. We're a podcast that focuses on our ever-changing planet and on the people at Eros and across the globe who use remote sensing to monitor and study the health of Earth. I'm your host for this episode, John Holt. Landsat 9 launched into orbit from Vandenberg Space Force Base on Monday, September 27, 2021, to carry on the legacy of a nearly 50-year record of continuous Earth observation that began back in 1972. The days leading up to the event saw guests from around the world descend upon Santa Barbara County, California, to watch the historic event take place. We were there for the launch and several days leading up to it. And over the next few weeks, we'll be bringing you some of the interviews we collected with scientists, government officials, and mission partners. For today, we're focused on the day before the launch. We met Assistant Secretary of the Interior for Water and Science Tanya Trujillo on Sunday morning at Space Launch Complex 3, where Landsat 9 sat inside the payload fairing of an Atlas V rocket. Tanya is an attorney and New Mexico native who's worked closely on water rights in the West. Some of that collaboration involved the Western States Water Council, an organization that has championed the Landsat program's value in monitoring water use. The council also worked with Landsat mission partners to advocate for the thermal infrared sensor, which we call TIRS, on board Landsat 8 and now Landsat 9. Tanya spoke alongside Tony Willardson, who is the council's executive director. Now you're going to hear a lot of background noise here, but that's because we were speaking about 200 feet from the rocket.
The Landsat program is very helpful to all of the Western states in terms of how they analyze the water use data, and it provides another tool that they can utilize through evapotranspiration analysis of what the supply and demand factors might be on a year-to-year basis. But Tony's the expert in this.
Well, thanks, Tanya. We appreciate all your support. The Western States Water Council actually represents 18 states, and our members are appointed by the governor. So we've been involved with Landsat because of the importance of being able to measure consumptive water use over the large regional scales, down to the field scale. Water rights in the West are based on that consumptive use, and Landsat provides a tool to be able then to verify water use. There are a number of different areas. I've said in the past, the Colorado River Basin, which is in a huge drought now, 22 years. Every drop of water is becoming more important, and Landsat helps us measure that. So whether you're in North Dakota or Southern California, it's important to be able to know what our water use is and how much water we will have available in the future. I should mention, too, OpenET, NASA's efforts to map evapotranspiration using Landsat and other information. And we are working with them as to how we can actually match that with our own water data exchange, which includes water rights and water use, and be able to evaluate in the future what water rights are being used and how much of that water is being put to use.
And this project is a great example of partnership between the federal government and the Western states, but also between Department of the Interior and our partners at NASA. Great to mix the portfolios of the exploration and science elements from both of our agencies. We, of course, have the land management responsibilities that we take very seriously and are working on a day-by-day basis. And this data that feeds in from the Landsat missions helps provide a base for our scientific work. I was speaking earlier with someone about the importance with respect to our wildfire analysis and the post-wildfire analysis that we're being able to help with. It's something that's becoming more and more critical in the context of climate change.
On that side, too, for the states, the water quality impact.
Yes.
We're seeing, the precipitation after the flood.
Yes.
It's been huge.
Water quality is a huge component.
And including now the states using the Landsat data to monitor harmful aquifers.
Yep.
And being able to address those issues.
Can you talk to us briefly about putting TIRS on Landsat 8 and now again on Landsat 9, why that was important?
That's what makes it key for us, that as well as the archive of the Landsat data that goes back to 1982, because that allows states to not only evaluate current uses, but what those uses have been in the past. And I would mention the credit we get for helping ensure TIRS was on 8 was because of bipartisan support in the Senate. We have support from 12 Western senators, 6 Republicans, and 6 Democrats all recognize the importance of this tool.
And that support has continued for this mission, Landsat 9. We'll have even better capabilities in terms of the thermal analysis and the improvements that are made, but also that continuity that you mentioned. So they'll be able to continue the records into the future.
Why is it important to have civilian satellites of this record?
I have served as a member of the Landsat Advisory Group. We looked at the possibility of privatizing the data, and I think because that data has continued to be free, we've seen an explosion in the application of the information that we wouldn't have seen. And I don't think there's any private satellite that has the thermal imaging.
It's one of a kind in terms of its longevity, but also that key element of it being publicly available information. And anyone with an internet connection can find the resources, can download them and utilize them. It's important to maintain that availability and that continuity as we go forward. Tony, how cool is it that we're here at the launch pad of the Landsat 9 satellite?
This is great. I got to watch Landsat 8 from quite a distance. And I still remember the picture of that cone and some of the promotional material from Landsat 8. And so actually being here this close and seeing it ready to launch tomorrow is really spectacular.
One of the water rights officials who hopes to tackle water scarcity in California is named Joaquin Esquivel. Joaquin is the chair of the California Water Resources Control Board, which administers water rights and oversees water quality. We met him at a winery the evening before the launch. He was on hand for an event called Landsat for Climate, during which guests were able to meet several scientists who use satellite data to study the impact of climate change on the landscape. You'll hear a reference to OpenET here, which stands for Open Evapotranspiration. That project is a partnership between NASA, Google, the Environmental Defense Fund, the Desert Research Institute, AEROS, and others that aims to use several satellite-based water use estimates to create an open-source tool for tracking consumptive water use across the western U.S. You're also going to hear the term HABs, which stands for harmful algal blooms. Those damage water quality and can threaten the health of humans and wildlife. My first question was, how do you know where HABs are happening?
Well, we use your satellites. They're an important part of really characterizing our water bodies these days because we don't have enough people everywhere, or people will tell us. They'll be like, look, we see instances of HABs happening. So there's a lot of community aspects with the work that we're doing on the HAB side as well.
So and then on the water rights side,
I'll be candid. The administration of water rights in the state of California is not a sophisticated enterprise right now. It is still challenged by a lack of data, a lack of quality data. And for us, it's even getting our diverters to report how much that they diverted in the last year. Yeah, it's very challenging. We only over the last few years, about a few years ago, for the first time now have a yearly requirement for all of our water rights holders. Some of them are only reporting every 4 or 5 years. It's a light touch system, as I like to say, in the state. But with Landsat and the ability to better calculate and know ET, it becomes a proxy for water use, right? So, especially because some diversions are very hard to measure directly because they may be using siphons, or there may be variable flows. So it's hard for the grower to know exactly sometimes how much they use. But with ET, you know exactly at least what gave off, and there's the equation. So that's why the OpenET project with the EDF, with NASA, with Google is important for us. It should create trust amongst the water users. It should create trust amongst us all to be able to see the same data and be able to say, yes, that's what I used. I think of like taxes, right? You can either make it very hard for everyone to pay taxes, or you make it easy for them to do things like report because we have data sources that aggregate at this remote sensing level so that you don't have to measure. But anyway, it's a sensitive but future discussion.
I suppose the idea is that you can say this is very much like your rain gauge. It maybe isn't quite as intuitive or tactile as rain gauge, but this is a measurement that it doesn't care who you are or who I am. It's just
the data is what it is. Exactly, and that's why OpenET and the ensemble of models is so helpful because it's not any one model. It's the aggregate of it. So that's where the OpenET project is so exciting.
Sure.
That's the space, I think, generally the water quality, water rights administration, the importance for us. For me, Our regulatory agency is 50 years old, and how it's going to function for the next 50 years is going to be really important that we start to leverage these 21st century investments that help us do more with less. Let us understand what's happening at the landscape scale, better manage water quality, multiple outcomes through, drought or flood, whatever it may be.
After the Landsat for Climate meet and greet, the guests took some time to eat. We used the break to catch up with USGS Core Science Systems Associate Director Kevin Gallagher. We spoke just before the second Landsat-related event of the evening, where we heard about how Landsat data helps California wineries manage water use. The sizzling you'll hear in the background is the sound of the flat grill. Here's what Kevin had on his mind the night before the launch.
Landsat came along in 1972 at a time when worldwide we started documenting significant changes in the temperature associated with climate change. And so the fact that we have a data record of monitoring on the Earth that coincides with this change, I don't think we've even begun to understand the significance of that. And so mining that data archive is one of the huge opportunities and challenges that we face. So a lot of appreciation. We're standing on the shoulders of people that built an amazing program, and the folks that dedicated a good portion of their lives to get Landsat 9 in the air. And we're so pleased that we have a spacecraft on top of a rocket today to be very excited about, and fingers crossed we'll be in space come Monday evening. But there's another aspect that I'm really focused on right now, and that's Landsat Next. This is the opportunity to continue the legacy far into the future. The Landsat data record is so unique. We're capturing most of the electromagnetic spectrum. There really is no other satellite that's quite like Landsat collecting the frequencies of the spectrum that we collect. And as we look at Landsat Next, I think the two primary goals is to broaden that collection, to collect even more of the spectrum, to address a wider array of user needs, and to continue this legacy, for another decade or more into the future.
There are a lot of satellites, a lot of commercial satellites.
Yes.
The open data policy means that everybody can calibrate to Landsat. Why is it so important to have this continuous record on the civilian side?
Yeah, no, this is a great question that comes up a lot. So, well, first of all, I want to talk about the free data policy, because that was a game changer. It was an incredibly brilliant move, in my opinion, on the part of the Department of Interior to release this to the world, and it really changed the world. I do a lot of work with international communities when it comes to geospatial data. And all of Europe, for example, they had a completely different model for charging for data that the government collected. And that's all changed. Now Europe's on board with open data, and it's the great equalizer. Basically, it brings everybody to the table to not only gain the value from the data, but also to add to the intellectual market, if you will, of ideas about an interpretation of the data. We're working in a resolution of 30 meters, and so the way to think about that is the size of an American baseball diamond. That's a size that really is great for regional studies, understanding Earth processes at a scale that is significant for everyone around the globe. The commercial industry is essential to what we do. There's a great partnership. They bring the technology development, instrument development to the table for Landsat. But in terms of them independently operating, launching their own satellites, they've been going after a quite different market of high resolution, the kind of thing that we all recognize when we go and look at an image of our house, for example. At the moment in time, there isn't a commercial provider that's providing the same level of data.
Because essentially we're looking at a wider swath of the spectrum than they're going for.
That's correct.
And we have that regional scale of coverage.
That's correct.
So that's one piece.
That's correct. There's another piece, I think, that involves, this consistency with this legacy. For all this data to come together and be valuable, you want comparability. You want comparability in different parts of the globe and also over a temporal scale of great periods of time. Ultimately, the commercial sector builds it, they want to license the data, and ultimately you pay for it.
And many times, you'll pay for it over and over and over and over again.
What else do we need to know about Landsat 9 and Landsat 9?
What else do we need to know? I think that a fair number of people understand that there's a variety of applications that come out of this. Vineyards use it to understand agriculture. The wildfire season, it's used there. I think the thing that I would like to get across, and my colleagues at NASA would agree, if you're familiar with the United Nations and their societal relevance approach, they've identified a couple of dozen worldwide societal needs. The Landsat program delivers across that entire spectrum. From a national asset, it's second only to GPS in terms of its value, and from a worldwide asset, it's similar. So some of the applications like famine, early warning system, it's like an immeasurable value to the human race.
We've been listening in on some of the conversations we had on our trip to California for the launch of Landsat 9. Thank you for joining us for this episode of Eyes on Earth, and be sure to come back for more from launch in the coming weeks. You can find us on our website at usgs.gov/EROS, that's usgs.gov/EROS, or you can find us on Apple Podcasts or Google Podcasts. This podcast is a product of the U.S. Geological Survey, Department of Interior.